In this video, we're going to be talking about a CLEP problem, actually two CLEP problems. We're going to discuss how to tackle them, and these videos also can be used in individual math courses like an Algebra 1 or Algebra 2 course. So I hope you're ready. Let's get your notebook and pen, paper and pen ready, everything you need, and let's talk about how the CLEP College Algebra addresses certain topics and how, by studying for the CLEP or College Algebra, you get a very good review of algebra. Let's start from the first problem. In the first problem, it basically asks you to find the roots of a polynomial, okay? Or like which of these has a certain root that is 1 minus I. That's what it says. So first we need to know what kind of topic we're talking about. In every math problem you do, you want to always ask yourself, what is the thing? What is the topic? What is the goal? What am I looking for? When you hear the word roots, right, you begin to think about quadratics. Now, in our algebra course, that's in chapter 9. In your textbook, it might be different. Never allow a textbook to box you in math. Textbooks and curriculum are just a guide. What you want to focus on is knowing what topic am I learning and how do I handle it best. So let's look at this topic called, finding the roots of a quadratic. Okay, we're finding the roots of a quadratic. So we have the roots of a quadratic. Now remember, a quadratic expression could be, this is a quadratic equation where it's x squared minus 2x plus 2. Please know that there is a full course you can watch later. We have courses on our Tools for Mastering Mathematics series. You can use the link in the description to sign up for my pre-algebra course, or Algebra 1, Algebra 2, or Geometry Trig. Those are the 3 courses we have. And then that prepares you for our Calculus CLEP preparation course, which you can also use the videos from that to study for the Calculus CLEP preparation. So basically, if you do math with us, you can get the college credit for college algebra, the college credit for trigonometry, and the college credit, for pre-calculus, and the college credit for calc. So that's 3 credits to start, 9 credits to start, and then you basically can go into Calc 2, Calc 3, linear algebra, and differential equations. That's the series, and we want our students to graduate with 21 credits of math in high school. That's how we roll. You're welcome to join us on that quest. But regardless of that, let's look at this problem. Which of the quadratic equations will give you the roots as 1 minus I? Well, they gave us 5 options. Let's look at the 5 options. This is the first option, x squared minus 4. Is the root of x squared minus 4 going to give us 1 minus I? No, because the difference of 2 squares will change it from x minus 4 to x squared minus 2 squared, which is equal to 0. And then we find the difference of 2 squares, x plus 2x minus 2. And then the answer for x will be minus 2 and plus 2. So that's the answer for A. This is a quick review of something called the difference of 2 squares. Let's look at option B. Option B gives you x squared minus 2x plus 1 is equal to 0. This is basically a polynomial with a leading coefficient of 1 for the x squared portion. So we call it factoring polynomials where A is equal to 1. That's what this topic is, okay? And we have it in our curriculum in lesson 6, chapter 6.3. We're factoring a polynomial where the leading coefficient is 1. So all you need to do is you need 2 numbers that multiply to give 1 and add to give -2. And if you do the work there, you find out that the x minus 1, you find that those numbers are -1 and -1, and the root ends up being 1, okay? The root of a quadratic is where it intersects the x-axis, by the way. So that's B. Let's go to C. C was x squared plus 1 is equal to 0. What are the roots there? Well, we solve for x, we do our work, and we find out that it's going to be plus or minus square root of -1. The square root of -1 is actually I. That's what we call I. It has applications in a field called complex analysis. Part of why smartphones work is because of that field of mathematics called complex analysis. Next time you see a mathematician, tell them thank you for what you do. The world works for the most part because of mathematicians. I was actually telling some kids today that in World War II, there's the whole decoding that was happening because of mathematics. Part of why the Allies won in that war, there's an element of this, is because of mathematicians who could decode things, right? There's a whole movie about this if you want to see it. So that's C. X is equal to I or -I. D is x squared minus 2. If we're going to solve that, that ends up becoming plus or minus square root of 2. Again, that's not the answer. But E in this problem, which is found in the CLEP College Algebra REA book, which you can buy from our bookstore if you want one. But in the CLEP College Algebra REA book, notice that I show my work here for x squared minus 2x plus 2 is equal to 0. I was telling the students today that in mathematics, There are times where you will see problems and your brain needs to automatically know the approach to use for that particular problem. When you see x squared minus 2x plus 2 is equal to 0, you should automatically know that you need the quadratic formula to factor it. You can't do it by AC method because you will never find two numbers that multiply to give 2 and add to give negative 2. You're not going to get that. So you know you're going to need the quadratic formula, which is minus b plus or minus square root of b squared minus 4ac over 2a. So minus b plus or minus square root of b squared minus 4ac over 2a. So that's called the quadratic formula. A is the number in front of x squared, b is the number in front of x, and c is the number there by itself. So you basically take those and plug them into this formula. We discussed this in chapter 9 of our curriculum for algebra and algebra 2. We do algebra 1 and 2 together to save students time so they can complete everything in about 12 months or less if they put in the work. And so this is what happens. You get minus b plus or minus square root of b squared minus 4ac over 2a. You do the math and you're good to go. We plug in the values, This section right here is important though, because there was a 2, a 2, and a 2 that was waiting there, and I basically canceled those out because they're all common in all three spots. That's a unique thing to remember with these types of problems, okay? So basically we plug in the values, and that's how we get our answer. The answer is E to this specific problem in the CLEP REA book. I believe this is number 24 or 25, which is completed from test 2 of the College Algebra REA book, okay? One more video for you here, which has to do with finding the inverse of a function. So this is a function, f of x is equal to 3x minus 5 over 2x plus 1. We're trying to find the inverse of that function. And the way we do that is we actually, first of all, change f of x to y. By the way, f of x comes from a mathematician called Leonhard Euler. He lived from 1707 to 1783. He was an amazing mathematician. He's my favorite, one of my favorites, apart from James Clerk Maxwell, if you count him as a mathematician. Maxwell was more of a physicist, but he was a mathematical physicist, and so I love Maxwell and Euler. Those are my guys, I call them. Okay, so y is equal to this. So if you're finding the inverse of a function, we discussed that in our curriculum, also under the function chapter, and we teach you about the steps for finding the inverse of a function. The way you do that is you set f of x as y, because that's what it is, and then you change the y to x and all the x's to y. If you want to find the inverse of the function, these are the first two steps. And then you solve for y. After you change this to x and that to y, now you solve for y. And that's all I'm doing here. I multiply both sides by 2y plus 1. We get down to this step. We continue our work, and we get to our destination. You can go back and watch this video. You can look at the steps. You can try it and then look at my work. But notice that the last step here, y can equal this. Or you can write it as f of the inverse of the function. You can write it like that. So you can write the answer like this, you can write the answer like that, you can write the answer like that, or you can write the answer as the last step. Those are all correct answers to this problem. It's very good to be ready. So here's one more analogy for you to go. In my book, Tools for Master Mathematics, I talk about how students need to be aware that sometimes in math, when you're learning a topic, it's not because of the application of the topic. It's actually because of the skills you learn as you learn the topic. So you learn things like critical thinking, you learn things like teamwork. Because sometimes solving math problems, you can do it better when you're on a team. So think about this question. When do you ever use the skills you learn in tennis in real life? Not really any other time apart from when you do tennis. But tennis is fun to play. I played tennis in college, and I also played soccer, intramurals, and ping pong and basketball. But if you play a sport, you are not doing the sport simply because it has practical applications for you later, because nobody takes a basketball and just walks around every day, all day. That's not what you play basketball to do. You play basketball partly because you want to grow in teamwork, because it's good exercise, and we can go on the benefits. That's the same thing with math. When you do math, you're building muscles and skills and abilities that will help you in life. And it's not all about the math problem itself, it's about the things it teaches you about life. So the other reason we do math is to stretch your brain. And when you stretch, I joke about this, you stretch your thinking and your brain, and then your brain doesn't necessarily come back to the same size, and that's good for you. Because there are some math topics that don't have application. I have to warn you. They are pure mathematic topics that we just teach you, and you're not going to use it yourself in your everyday life, but they're going to help you to learn to think better. So lastly, we look at that analogy, but then I told my students, especially when it comes to this quadratic problem, that when you see a problem, as a mathematician, you need to grow, or as one who wants to be a good math student, you need to grow in your ability to know how to tackle problems quickly and effectively and efficiently. So think about it like a point guard in basketball. When they drive up on the court, They are looking and seeing, okay, somebody is running and cutting. Oh, they're open. The point guard automatically knows I'm distributing the ball. Whether I'm passing it straight or I'm dropping the ball, it is important that the point guard is aware of their surroundings and on what the best option is every single time. In mathematics, that's what you want to grow in. Growing your skills and in maturity in knowing how to tackle problems well. I hope this video was helpful. We will be doing more in this series of math problems for the public, and then our math courses are available, as I said, on our website for if you want to purchase those. Take care and have a blessed day.